Hello, today we're going to look at one of the problems that often appears in exams or homework problems. So this problem is good in a way that it helps you to dissect the concept of the work by looking at the impact of different forces and how these different forces contribute to the work. So let's read the question together. A block is pulled by a 20 Newton force on a rough surface for 8 seconds, as shown in the figure. The coefficient of kinetic friction between the block and the surface is 0.1. Calculate the followings: the work done by the 20 Newton force, the work done by the friction, and the work done on the block. In other words, the net work, the total work. Okay, let's start by redrawing this diagram and identifying the forces. So here is our block. You have a weight that's acting downwards in negative y direction, if you will. You have a normal force exerted by the floor or by the surface, which is upward in a positive y direction. You have a friction force that's in a negative x direction or backwards, and you have a force F that's acting at an angle of 37 on the block. So it will have two components, x component and y component. And we know how to calculate the x and y components, right? So if this is your force, we can imagine a rectangle, and this is going to be your right triangle, and you know that fx will be equal to the f times whatever the cosine of this angle. And this part, which is the same as this part, is going to be fy, and fy is going to be equal to f hypotenuse times sine of the 37 degrees. Hence, we can find the forces, components of the force to be 16 and 12 newtons. Now, let's draw a free body diagram. So what do we have? Friction force, x component of the applied force that's pulling forward, and you have mg, which is downward, and you have normal force and Fy acting upward. Since our block is not moving up or down, these forces are balanced. What does it mean? Y component of the force plus normal force applied by the surface has to be equal to the mg or weight of the block. From here we can write N to be equal to mg minus F sub y, which is just 80 newtons because it's 8 kilograms and g is 10. 80 newtons minus 16 newtons equals to 64 newtons. We can also calculate the friction force, which is coefficient of friction times normal force. We know the normal force, we are given the coefficient of friction, so our friction force comes out to be 6.4 newtons. So now we are ready to calculate the work. Hold on, we know that work is force times distance. We are not given the distance, but we are given the time that we apply the force, so or time the block travels. So we can calculate the distance traveled using this information. How are we going to do this? Well, so let's look at the forces along the x direction. Net force is going to be Fx, which because block is moving in this direction, minus friction force, which is 16 newtons minus 6.4 newtons, which is going to be equal to 9.6 newtons. And from the Newton's second law, we know that net force has to be equal to the mass times acceleration, or acceleration is going to be equal to the net force, which is 9.6 divided by the mass of the block, which is 8, which comes out to be 1.2 meters per second square. Now we have the acceleration. We can use this formula for the distance, which is d equals v naught, initial velocity, times t plus 1/2 at squared. Since the block is starting from the rest, we can set this to be 0. So 0 times 8 seconds plus 1/2 times acceleration times 8 squared comes out to be 38.4 meters. So, I mean, it's important to note that even though problem does not state that the block starts from the rest, that's something we assume, right? So initial velocity is 0. Now, We have the distance, we have the different forces, right? So let's look at part A and calculate work done by 20 Newton force. So here I'm going to just put out solutions to all parts, but let's look at the work done by force F, W sub F. It's going to be X component of the force times D, right? Because work is only being done, object is only moving in this along this direction, and the only force, the only component of the force that's responsible for moving the object along this direction is the X component. So this is going to be equal to 60 newtons times 38.4 meters, which comes out to be 614.4 joules. Now work done by a friction force, W sub F is going to be equal to friction force times the distance traveled. Friction force is 6.4 newtons and the distance again 38.4 meters, and we just multiply them, but we have to keep in mind the negative sign. So it's actually work done by friction. It's going to be negative, right? So it's going to be in a backward direction. So the net work, when we're calculating net work, it's important to keep this number in mind. So it's going to be negative 245.76 joules, right? Now we have to calculate the net work done by the block. So work that is done by us pulling, and friction force, which is usually dissipates as a heat when block rubs against the surface. So you have 614.4 joules minus 245.76 joules, which comes out to be 368.64 joules, and that's the answer for part C. And that's pretty much the solution for the problem. Thank you.